Hi everyone, and welcome to my lightning talk. I'm going to talk today about how to make Grand Theft Auto using CSS as much as possible. So for anybody who was born under a rock or young, this is the Grand Theft Auto that I'm talking about. The top-down original version. This was the first Grand Theft Auto. Still probably one of my favorite games. And anyway, so let's start with what is CSS 3D. CSS 3D, in case you didn't know, is a method of manipulating DOM elements in 3D without any plugins or JavaScript, so it's just completely CSS. You can use the transform properties. These are all the standard transform properties that you would normally use with CSS. And you can also use matrix transformations if you're a complete psychopath. And animations can be achieved using standard CSS transitions, the same as normal 2D CSS. And most importantly, everything remains part of the DOM. So you have all the standard HTML element properties, and you can listen to events as well. So this is how it started. I wanted to try and make a demo that shows what CSS 3D can do. As with, I do this a lot. If there's a new feature or something like that coming out, I tend to just sort of mess around and see what you can do. I come up with ideas all the time. I just wanted to come up with I just wanted to make a cube, not get carried away with it, and just make a cube, just make it move around the screen a little bit. So anyway, this is what my cube turned into. Oops, I'll just move me car around here. So as you can see here, the cube sort of evolved pretty quickly into a 2D array of cubes, and there's a few graphical glitches there, as you can see. I'm not sure what's going on with the browser painting at the edges, but the thing is the Z order issue. So I realized that just using CSS 3D alone and just moving it around with JavaScript wasn't gonna fix the Z order issue. I had to add some JavaScript to change the order, the layering, so that you can see the Z fighting even now with that code in there. This is the code here. Also, don't judge me for using jQuery. I did this in a hurry. So you can see here that what it's doing is it's setting the Z index for the it's radiating outwards from the center of the screen, so that the divs in the center of the screen are closest to the camera, and then as it goes out towards the edges, they get further and further away. It sort of works, but it doesn't work for the big buildings. You also notice here, any eagle-eyed person may have seen this double tilde operator. I use this a lot in computer games. It's called the bitwise double not operator. It works a little bit like the math.floor. It's basically the same as math.floor, except math.floor always rounds down. Bitwise double not rounds closer to zero. In a lot of cases, if you're using if you're trying to round down positive floats, then the bitwise double not operator is a lot faster. Actually, not so much in Chrome, but in every other browser, it's considerably faster. So I had to switch to 3JS. To fix that Z order thing. Well, when 3JS actually has a vast array of matrix utilities, there's no reason why I should mess around with matrices myself. It can support multiple rendering plugins. You can render to Canvas, or you can render to like ASCII or all sorts. There's so much you can do. And it now includes a CSS 3D renderer. When I did my original CodePen demo, there was no CSS 3D renderer, but when they added it, I thought, well, it was worth sort of reviving the demo and having a go and seeing if I could make it better. So initialize 3JS the same way as you normally do. You create the scene, you choose what renderer you want, and you just add the container to the DOM. Super simple. So the first thing that I needed to do was create a map. The map structure is a one-dimensional array of strings. It's actually a two-dimensional array because JavaScript's kind of crazy and it can treat strings as arrays as well. So you can actually access each element as if it was an array. And so I did it like this just so that I could sort of visualize it better. If you were doing this in any sort of grown-up language, then you would specifically type these before, and not just use the sort of weird quirks of the language in order to do that. The buildings are just made up of classes essentially. All the styling I wanted to have in CSS, there was as little. I wanted JavaScript to do very little styling at all. So the SCSS there, look, there's a pseudo block, and that gets inherited. All these other classes here just inherit that pseudo block, so everything's all in one place, so it's easy for me to edit. So the adding the map is going through a 2D array, pretty standard stuff. If it's an X in the string, then it places a building. The building's just made up of divs. Each of the elements get added to that. Each of the divs get added to separate CSS 3D objects, and then if it's not a building, then it's just a bottom div, and then that just gets added to the scene like that. And then very quickly, the render loop is super standard. It's just a basic render loop. You just request the animation frame, and when that times out, it updates and renders. So that's what it looks like. It creates that 2D map. Then adding the car, again, using SCSS to create the elements, and the object is just inherited divs again. And oops, I'm just zipping through these slides here. So that's the car. And then the next step is to make the car move. And so it's just using basic trigonometry. I'm converting angles to radians using math.sin, math.cos to work out the new X and Y positions. That's the code there. This is all open source code. I'll give you a link at the end of the demo. So now it's moving around like that, and I've got the wheels rotating slightly. You can drive through the walls. So the next step is to do collision detection. The collision detection was just a simple 2-point collision detection. I didn't want to go too crazy. It was just to prove that this works. So there's a front point and a rear point, and a little bit of maths there just to make sure that we're not going over the edges of the map. And essentially all it's doing is it's working out if that front point is in a map square that's got an X in it, and the same with the rear point there. If it is, then it just inverts the speed and then it divides it by 2, just to give it a bit of speed loss when you bump into something like that. Bonk. Right, so that's collision detection. So the next step was to add textures to make it look pretty. I just created a texture map here using some copyright-free images that I found on Google Images, and again, this is all happening in CSS. So there's nothing sort of JavaScripty going on here. It's all just, and it looks like that. So we've got a nice city to drive around now. Although it's looking a bit flat, so the next step for me was to have a look at lighting. So in computer games generally, there's something called light mapping. If you've done any computer game development in the past, you probably know what light mapping is. It's pre-calculated lighting that gets overlaid over textures within the scene, and it sort of creates this sort of fake lighting and shadow effect. In a similar way, what CSS wanted to do was just use classes to style certain elements and say that certain elements were in shadow from the buildings and what kind of shadow that was. So there was 3 types of shadow: full shadow and 2 half shadows. And so I had to use background layering for this. I hadn't really used background layering before, so it was quite interesting to find out how it works. You add backgrounds in order that you want them to appear from front to back. So in this case, in order to get this effect, what I wanted to do was use a linear gradient and then a background image behind it. So the background image is whatever was being set for, so that would be the image map. So that gives us this. I've also set some background colors on the buildings as well, on the building sides, so you can see that one side is slightly darker, well, 2 sides are slightly darker rather. So that gives us a lot more sort of visual depth to the scene. Okay, so the next step is to add pedestrians. Obviously, it's not Grand Theft Auto without pedestrians. In order to keep it a bit lighter, I've decided to make them zombies. So this is the zombie GIF that I found. I've put a link to the source there. And I use the A-star algorithm to move them around the scene. A-star is a great way to create, to do pathfinding in a two-dimensional map. And what you do is you give it a start point and an end point. It will use depth first search to work out the way, the quickest way through the map. I use it on a lot of games in the past. You can also add weighting to each of the grid squares so that it knows that some bits are harder to walk through, like sand or mud or something like that. In this case, so this is the link to the A-star algorithm that I used. And yeah, so adding weight to each tile here. In this case, I wanted the pavement to equal 1. I wanted the road to equal 3, and all the buildings to equal 100. So it will always try and find the easiest path to get from A to B. If it's going to take too many pavement tiles to walk through, then they'll cut across the road, which makes it kind of a bit more sort of realistic. And then the path detection is pretty basic. It just uses lerping or linear interpolation to go from A to B. There's the linear interpolation. And what that means is it's going from 0 to 1 and working its way from A to B in that respect. And then when it gets to to B, it works out what the next node is in the graph. And also added some collision detection as well. Super basic, just bounding box collision detection. So now when I drive around, hoover up the zombies. I've included all of these slides in the source code, so if you clone the code, you can you've got all the slides available. If you want to go through them yourself at a more leisurely pace than what I'm going through right now. So the next part is to make it a game. Essentially, all I'm doing here is just adding a score, and when the pedestrian dies, then it just the score gets added. Again, very simple, and then adding the UI there to make it work. So just run that guy over. There's $100. So you're getting paid to run over zombies. Cool. So the next step, this is where I got carried away, because I was just like, what, this is getting stupid now. I've made the game. I've added pedestrians. I've added collision detection. The first step is to make tire marks. So the tire marks are actually just a massive canvas that goes over the whole map. And there's all the code there. It shows you how it works. It's constantly updating on each frame and then drawing a line between the previous mark and the new mark. And you can just drive around like that and it will just make the tire marks. And then I wanted to add a bit of blood splatter as well. So there's the blood splats. And then I updated the skid marks thing to include blood on the tires as well. So as you drive around, well, let's find a zombie, splat. And then you can see that the tire marks go a bit red when you drive over them. There you go. A lot of fun driving over zombies. So performance-wise, getting on mobile, it's ridiculously fast. Actually, on Safari, it's ridiculously fast. For Chrome, for some reason, it lags a bit. But this is the thing. It's not really designed for making games, but you can make games with it. And most importantly, it's really good for making 3D multimedia experiences. The performance does vary massively between browsers. And if your website doesn't allow you to run zombies over in 2021, then how can you be taken seriously? So yeah, get on GitHub, download the code, and I want to see what you can do with it. Thank you very much.